Okay, you need to have your radical expressions and equations notes booklet. Not the workbook, but the one where you're putting your notes. And when you open it up to that first page, we have taken notes over simplifying radicals. So you should have on the left-hand side all these notes over simplifying radicals. Okay. Then you should also have on the right-hand side all the notes we just took over simplifying with our variables. Okay, so if you need to pause the video and go through either one of those, you need to do that. What I want you to do is flip to the next page, and we are going to take notes over multiplying radicals. So on the left-hand side, okay, all I did was flip the page. I want to make sure everybody's on the right page. So flip the page, and on the left-hand side, write multiplying radicals. Now, there are some rules that we need to go over when we are multiplying radicals. So first of all, let's talk about methods. Now, I know you're kind of tired of the different methods. I've got methods in quotations because it's not technically a method, it's just really more of a process that you want to take. For multiplying radicals, some people will multiply everything together first and then simplify. Or some people will simplify everything first, then they'll multiply, and then, that should say then, simplify again if necessary. So the reason some people choose this one is because if you multiply and then simplify, sometimes you're dealing with some large numbers. This way you may get away with not having to deal with large numbers if you simplify first. However, there is always that chance that you may have to simplify again. So just whatever process you want to take. Not really a method, but more of a process. Now, kind of a rule for multiplying radicals. You do not need like radicands to multiply. Remember, our radicands are the numbers under the radical sign. And I bring that up because when we start talking about adding and subtracting later, that's going to be extremely important. But right now, you do not need like radicands to multiply. So let's do a couple of examples. So example 1, we're going to take the square root of 32 and multiply it by the square root of 5. And with this example, I'm going to kind of show you both of these methods here. The first way is to multiply and then do all the simplifying after that. So with multiplication, it's very simple. You just multiply your radicands. Now, if I had coefficients out here, like say there were a 3 or a 2 or something like that, I would multiply those. Now, I do have coefficients. This is understood to be a 1, and this is understood to be a 1, and 1 times 1 is 1, but we don't have to write that. So, rule for multiplying, if you need to write this, write it. Multiply your coefficients, multiply your radicands. Write that in your notebooklet if you need to. Now, our coefficients, like I said, are just going to be 1, so we don't have to write that. So all we're going to do is just multiply 32 and 5, and we get 160. So that's the multiplication part. Now, what we're going to do is we're going to simplify that. Now, we've simplified these several times before. We've actually simplified the square root of 160 already. The largest perfect square factor that will go into 160, hopefully you've already written it, is 16. And 16 will go into 160 10 times. Now, if you picked 4, 4 will work, but it's not the largest perfect square. You've got to do the largest one. And then we need to start doing this with a little less work, a little less breaking it apart. To break the 6 out of jail, to get it outside the radical sign, we have to take the square root of 16. So the square root of 16 is 4, and then we cannot take the square root of 10 evenly, so it's just going to remain inside the radical sign. And there's our answer. So we multiplied our radicands, got 160, then we simplified. Now, if you wanted to look at the simplify then multiply part first, This would be like method 2. Okay, this is, I'm going to put a 1 here. This was like method 1. This would be like method 2. You're going to have to simplify first. Well, I need to simplify the square root of 32. So I think, what's the largest perfect square factor that will go into 32? And you want the largest ones, you have to be very careful. Okay, if you say 4, again, yes, 4 works there, but it's not the largest one. The largest perfect square that goes into 32 is actually 16, and it goes into 32 2 times. So the simplified form of 32, square root of 32, is going to be 4, because that's the square root of 16. Square root of 16 is 4, and 2 remains on the inside. So what I did for method 2, it says to simplify first. I simplified the square root of 32. Now, as far as the square root of 5, I can't simplify it. So what I'm going to do, I'm going to keep everything lined up here. I'm just going to bring it down. There's nothing to do with that 5. I can't simplify it. So there's my simplify. Then I would multiply them. So now I do actually have a coefficient that I can visually see. Here's a 4. And again, this is understood to be a 1 here. So if I multiply my coefficients, 4 times 1 gives me 4. And then if I multiply my radicands, that would be the square root of 10. Because 2 times 5 gives me 10. So you can see either way, you're going to get the same answer. It's just whether you want to simplify first, then multiply, or if you want to multiply, then simplify. Now keep in mind, again, you may have to simplify again in method 2. We didn't have to here, but there are times that you may have to. Of course, it's up to you how you want to approach those problems, and you may mix it up. You may multiply first sometimes, you may simplify first sometimes. That's totally up to you. Let's look at one more example here. Example 2. Example 2, we're going to throw in some variables. So we have the square root of 5t times the square root of 7st. Now, I'm going to do multiplication and then simplifying here, and the reason for that is because I can't simplify this and I can't simplify this. So the only option I have is to go ahead and multiply. Now, I told you that we had to think about multiplication, the exponent rules when multiplying, and that would come back, and that's exactly what we've got here. So I want you to focus on the radicands, okay? This is the coefficient of t under the radical sign, and 7 is the coefficient of st under the radical sign. I've got to multiply both of those together. So if I multiply 5 and 7 together, I get 35. And then look at your variables. I've got t times t, or t times st if you want to leave it all together. But if I do t times t, that gives me t squared. And I don't have anything else to multiply the s by. There's not an s in here. We need to keep our variables in alphabetical order. So s will be here, and then t times t gives me t squared. So 35st squared. That's what you get when you multiply those together. Now, like it says up here, if you multiply, then you have to simplify. Now, if it's necessary. Well, looking at this at first glance, you may not think so, but there is some simplifying here. 35, even though it's a larger number, is actually cannot be simplified. There is not a perfect square factor that will divide into 35. You can try. You can try 4, 9, 16, and 25, but they will not divide evenly. So 35 is just going to stay 35. S is that exponent of 1. It's that odd exponent that we talked about, and it's a 1. I can't do anything with it. It's stuck. But if you look at t squared, this right here is an even exponent, and it is a perfect square. Even exponents are perfect squares. So I can actually simplify this further by taking the square root of t squared, which is going to give me t. I didn't leave myself enough room there. The square root of t squared is t, and then left inside is 35s. So your final answer is t square root of 35s. Now that's multiplying. Okay? Now, slide your paper over to the other side. Stay in your note packet, slide it over to the other side, and here is dividing. There's a couple of rules about division that you need to keep in mind. No radicals can be left in the denominator. That means once you do all of your simplifying, the denominator does not have a radical sign. And if it does, we'll talk later about what to do with that. And you have to simplify all your fractions. Now you can simplify before you start, or you can simplify after you've taken the square root. But either way, you have to make sure you simplify your fractions. So we're just going to go straight into, we're going to do 3 examples in here. So let's do example 1. We're going to look at the square root of 128 divided by 8. Now, hopefully you're getting in the habit of looking for perfect squares, and you'll recognize that neither of these are perfect squares. So you wouldn't want to start trying to take the square root of them because they can't. So right here where it says simplify all fractions, try that first. Take 128 divided by 8. See if you can simplify that. Okay, and you actually can on this one. I would always try that. Try to simplify first. It may make the problem a lot easier. 128 divided by 8 is actually 16. So I no longer even have a division problem. I took care of the division. I just have to take the square root of 16, which is 4. Okay, and I would like to throw in here something I haven't talked about in this unit, but we're only going to deal with the positive value because we've talked about the square root of 16 could be a positive or a negative 4. We're only going to focus in this unit on that positive solution for the square roots. All right, example 2. Let's look at this one. This one's easy. Square root of 36 over 49. Square root of 36 over 49. Now, this is an actual division problem because if you try to divide those, you can't. You get a decimal. They don't simplify as far as a fraction. So this is where we're going to bring in our division rules. Okay, the division rule for radicals is that I can, and it's just like the multiplication rules, I can take the square root of the numerator and I can take the square root of the denominator. We've talked about that with multiplication where we can break it apart. Okay, you may get in the habit of not breaking it apart when you're writing it out, but this is what you're actually doing. You're taking the square root of the top and the bottom. So the square root of 36 is 6. The square root of 49 is 7. And there's your answer. 6/7, and you can't simplify that any further, so you're done. All right, it's that simple. Now, example 3, we're going to bring in some exponents or some variables with our exponents. So let's do 8x to the third over 50x. And again, if you look at this, 8 and 50, neither one are perfect squares. So it's kind of like what we did up here. 50 doesn't divide into 8 though. We need to just simplify this fraction. Okay, so let's just focus on the 8 and the 50 first. If I simplify 8 over 50, type 8 over 50 in your calculator if you need to, and simplify it. And you're going to get 4 over 25. That's the simplified fraction form for 8 over 50. Now, let's look at our variables. Going back to, we've talked about the multiplication rules when we did multiplication over here. Now we got to talk about the division rules. When we divide like bases, we have to subtract our exponents. There are 3 x's across the top and 1 x across the bottom. That means if I eliminate the x they have in common, I'm left with 2 x's on the top. That's our division rules for exponents there. And now I'm back to what I had over here in example 2. I've simplified, that's what I did up here, except I had variables this time. Now, if need be, you may not need this, you would take the square root of your numerator and the square root of your denominator. And that would be it. Square root of 4 is 2. Square root of x squared is x. And the square root of 25 is 5. And that is dividing radicals. Now what you need to do is you need to turn in your workbook. These are your notes. You need to get your workbook out and refer to the 4 questions that you need to do for multiplying and the 4 questions for dividing.